Okay, quick review so you'll have something to pull out of your notes. The notes I've provided for you and have listed as resources on each of the lectures are wonderful sources, and they have all of the information you need from this. Okay, so you may want to organize that out. Okay, first things first, you have to know the properties of a perpendicular bisector, of an angle bisector, of a median, and an altitude. The names give away what they do. Excuse me, forgive me. Perpendicular bisector is perpendicular to a segment and it cuts it in half, 2 equal parts. Okay? An angle bisector cuts an angle in half, leaving 2 equal angles. Remember that an angle bisector is equidistant from the sides of the angle. Okay? Median. Think median on the highway. It's the center. So a median goes from a vertex to the midpoint of the opposite side. 2 equal parts of the opposite side. 2 equal parts. Okay? Notice I'm emphasizing things that are probably going to be question-like. Altitude. Altitude is a perpendicular segment. Okay? Remember, the altitude is the only one of these that can be outside of the triangle. Remember I showed you the example of the obtuse triangle, and the altitude would be outside. Okay? Concurrent lines are, you've seen it in the text, you've seen it in your notes. Okay? 3 or more lines that have the same intersection point. Okay? That's called the point of concurrency. Each of our 4 concepts here, or lines, or segments, okay, have a specific point of concurrency. For perpendicular bisectors, when they all intersect, it's a circumcenter. When angle bisectors intersect, it's an incenter. When medians intersect, it's a centroid, which sounds like a new Marvel superhero. The altitudes, remember, they may intersect outside as well. Okay, so that's called an orthocenter. When I was growing up, Ortho was a mattress company, so I was writing that down and I was thinking, I wonder if they sell mattress. Anyway, inequalities, one triangle. Remember the exterior inequality theorem. Remember we had the exterior angle of a triangle was equal to the 2 interior angles not next to it. Okay? In this case, the exterior angle is greater in measure than either of those individually. Okay? Angle-side relationships in a triangle. The longest side is always opposite the biggest angle. That's how it is. Okay? When we talk about triangle inequality, we also have to think about the numbers that make up those lengths. Okay, remember we said that any 2 had to add up to be greater than the third. That's going to be one of the problems, I guarantee it. Not only on the test, but also on the final coming up. Trust me on that. Okay? Also, the range of lengths, okay? It can be from how small to how large to fit that triangle. Remember, we subtract for the lower side, add for the larger side. Okay, that's the range of sides. When we talk about inequalities of 2 triangles, okay, I had the written out hinge theorem. Okay, that just said if I have 2 triangles, and I got to make comparisons. If I've got 2 sides that are equal to each other on both triangles, if I have the angles, I can talk about the sides. If I have the sides, I can talk about the angles. Okay, that's the hinge theorem. Okay, and that allows us to work on that. So that's the problems as well. Okay, so when you see this, know that you've got a review worksheet coming up on the next day we meet. Okay, take care, enjoy your day.